Hi guys. So we're going to go through the slides for today and then I'll tell you what questions you're able to work on. So we left off and we should be on slide 14. So up till now we talked about atomic theory, how the atom developed over time. So now this is where we're at. So the mass of an atom is concentrated in the nucleus, and that's where all the protons and neutrons are. And then we have the negatively charged electrons that are traveling around the nucleus, but they have a very small mass that's basically negligible. So if you look, this table down here kind of summarizes all that. So we have the electron that's outside the nucleus, protons and neutrons that are in the nucleus. An electron is negative and a proton is positive, and they're equivalent in their quantity of negative and positiveness. So unit charge is -1, a unit charge for a proton is a +1, and of course a neutron has no charge. Then the mass, if you remember from last year, we did a lab where you had to pile up like popsicle sticks or sand. And remember, the electron's mass was basically negligible. You had like one tiny little piece. And then the protons and neutrons are almost the same. They're basically one atomic mass unit. So they came up with that AMU because if we use this kind of mass, the scientific notation, the numbers are so tiny that it would be difficult to even really represent it. So they just said, okay, well, we're going to make a proton and a neutron. They're going to be about one atomic mass unit. And then in electrons, remember we said it's like 1/2000th approximately. So it takes 2,000 electrons to be one proton. So its mass is basically negligible. All right, so we're talking about the atom, so we use this notation here. So the C being, of course, the atomic symbol. The Z, we didn't necessarily really refer to them as A and Z, but the Z, the bottom number, represents your atomic number, which remember the atomic number is the number of protons, and the mass number is the top number, which is your protons plus your neutrons. So if we look at this atom here, we've got carbon. Carbon is number 6 on the periodic table. Its atomic number is 6, so it has 6 protons. If it's a neutral atom, then the positives and negatives have to be equal, so you have 6 protons and 6 electrons. And then to get the number of neutrons, remember if this is protons plus neutrons, and this is protons, if we subtract the two, then we get just the neutrons, so 6 neutrons. All right, so atomic number, the Z, the bottom number, represents the number of protons in an atom. It determines the identity of an atom. So it's atomic number on the table. Nothing else has that number of protons. Nothing else has that same identity. So the carbon atom is 6. So any version or isotope of carbon is always going to have an atomic number of 6, and it's always going to have 6 protons. Okay, so what is the name of the element with Z = 8? Basically, they're saying which element is the atomic number 8. So if we look up at the reference table, atomic number 8 is oxygen, and so on. So basically, we're just looking up the atomic numbers for those. I'm not going to take the time in the video to look those up, but basically the name of the element with that atomic number. And remember, atomic number is number of protons, tells you its identity. All right, then we have mass number, which is the total number of protons and neutrons, so the sum of those. So protons plus neutrons is the mass number, and that's going to be the little number that's up in the top. So if an atom has 7 protons and 7 neutrons, what is its mass number? So mass number is protons plus neutrons, so it would have 14, 7 plus 7, 14 as its mass number. And then if we wanted to name the element would be the element that's number 7 on the table because it has 7 protons. The next one, if an atom has 92 protons and 146 neutrons, what is its mass number? So again, we would just add those two together, and that would tell us what its mass number is. And if we wanted to name the element just matches the number of protons. And then the last one, which element has 114 neutrons and a mass number of 190? So if a mass number is neutrons plus protons, if we did the mass number minus the neutrons, that would give us the number of protons, and then protons would tell us what element it is, because that's the Z, the atomic number. All right, and then the chemical symbol, an element's represented on the periodic table by its atomic symbol. Carbon is represented by C. Iron is one of those that goes by like a Greek or Russian or Roman, so it's Fe for ferrous or ferric. Xenon is Xe. So basically, what's the chemical symbol for an atom with 9 protons? If it's 9 protons, then it's number 9 on the table. So you just go, you look up number 9 on the table, and you would write the chemical symbol. Remember, it's always going to be just one capital or a capital and a lowercase, never 2 capitals. Okay. What is the chemical symbol for an atom with A equaling 35? So A, remember, is the mass number, and Z equals 17. So if we want the chemical symbol for it, all we care about is the 17, which is the atomic number. So we go look up what atomic number is 17, which is chlorine. So capital C, lowercase l. And then what is the chemical symbol for an atom with a mass number of 31 and 16 neutrons? So again, we can't tell what the atom is without the atomic number or the number of protons. But the mass number is protons plus neutrons. So if we do 31 minus 16, that will tell us how many protons we have, and then we look up that number on the table to tell us what atom it is. Okay. All right, and that's it. That's where we're going to leave off. So we'll, oh wait, no. No, we can do this one. So what is the X for each of the following? So as far as the atomic symbols now, so finding the missing pieces. So if we're trying to figure out what X is, in other words, what the chemical symbol is, then we just pay attention to the atomic number. So if the atomic number is 6, we look up what number 6 is, carbon, so the X would be capital letter C, or X, or Cl, or Fe, or whatever the element is. We look up number 12, we look and see what number 12 is on the table. Whatever number 12 is, that's going to be our element. And then same thing, we look up what number 52 is. So the top number doesn't have anything to do with identifying what element it is. We just pay attention to the bottom number, the atomic number. And then at the bottom part here, it kind of copied a little bit funny, like the A should obviously be up here. So it's A, 17X with 19 neutrons. So I want you to find the missing information. So first off, if it's number 17, that tells us what X is. So number 17 on the table is chlorine. So X would be Cl. And then to get A, which is the mass number, it'd be the protons plus the neutrons, and that would be our number up at the top. This one, we'd look up what number 27 is on the table. That would tell us what element it is, because that's its atomic number. And then to get the number of neutrons, if this is protons plus neutrons, this is just protons. If we subtract those two, that will give us our number of neutrons. Over here we have lead, so Pb. So we can get Z by finding Pb on the table. Find what number Pb is on the table. That will be what Z is. That's going to be our number of protons. They're telling us 125 neutrons. So once I look up and know Z, Z plus the 125 will give us our A, will give us our mass number. And then same thing down here. So we've got the mass number of 40. We know there's 22 neutrons. So if this is protons plus neutrons, we do 40 minus 22 to give us our atomic number. So that would give us Z. Then we look up that atomic number on the table and get the symbol that it belongs to. Okay. All right. So we'll leave off there, and thinking about what you guys are able to do, I'll post those questions for you to do in your question bank. Okay. So basically we did slides, I think 14 through 19. Thanks. Bye.